Hello everyone, this is Miss Salter, and I am going to be going over some problems from worksheet number 3 for our reaction conversions. This worksheet focused on liters to liters, or grams to liters, liters to grams, things like that. So we're going to start off with two problems here. I'm going to load this PDF with my work on it onto Google Classroom, so you can see it yourself. But for tonight, we're just going to look at about 4 problems here that I noticed people on the survey didn't quite understand. We're going to take a look at these and highlight some of the things that people might not be quite understanding with these problems. So number 4 here is a good one to start with. This is a liters to liters problem. So we got liters to liters here. We're starting with our equation, which is C3H8 plus 5O2 yields 3 CO2 plus 4 H2O. This is a combustion reaction. Our mole ratio is 1 to 5 to 3 to 4. And we are given this part here, which is 20 liters of O2 yields how many liters of CO2? And so we start out with our plan. We're going to go liters to moles to moles to liters. Our conversion, we're using our 22.4 liters for both of these guys. 22.4 liters of oxygen equals 1 mole of O2. 22.4 liters of CO2 also equals 1 mole of CO2. The part here that really kind of has the most importance when trying to figure this out is this part here in the middle, which is our mole ratio. So when we look at this, we can see how we set it up. Mole ratio, of course, in the middle here, under the blue line, is 5 moles of O2 equals 3 moles of CO2. We get that from our mole ratio. So when we set it up, we start with our given 20 liters of CO2. Then we bring down each of those mole ratios, and we're putting what we want to eliminate on the bottom. So we are eliminating the liters of O2 first over the moles of O2, then the 5 moles of O2 on the bottom with 3 moles of O2 on the top, and then 1 mole of CO2 on the bottom with 22.4 liters of CO2 on the top. So each of your arrows in your plan is a conversion. Each of your conversions sets up as one of these fractions. The cool thing about going from liters to liters is we can go ahead and eliminate these two, and then we're just doing 20 times 3 over 5 equals 12 liters of CO2. Liters to liters is pretty simple because you're just using 22.4 liters of one thing to 22.4 liters of the other thing. You just have to do the mole ratio in the middle. Okay? So, if we're going to go to another one here, I think 6B was another one that people wanted. And this one is the same way. Same thing, this is liters to liters. So we are starting with this 75 liters. Here. We're looking for liters here. This one we're going CO to O. So we have our mole ratio right here. That's what we're going to be looking for. And actually, I should have done that in blue instead, because that's what I was kind of doing that in blue. Okay. And so that's this one here, and then this part right in here. That's where we get that from. And And if we're looking at the liters to liters, that's this guy here and this conversion here. They're going to cancel out because we have 22.4 on the bottom, 22.4 on the top. So then we're just basically dividing our 75 liters by 2. So we get 37.5 liters of CO2. Just working with moles and liters on these two examples. Next thing we're going to go to is we are going to come up here to number 3. Now, number 3 uses the same equation as number 2. I think it was number 2. So let me just come in here and make sure we're not using this part and we're not using, grams to liters. Oh, I don't have my plan in here. That's not good. So the plan is going to be grams N2 to liters N2. Oh, no. No. All right. It is grams N2 to moles N2. Oh, this one gets fussy. Pull that back up again. And we're going to go back over to this part here. Make sure I got everything. This is moles of N2 yields mole of NH3 to liters of NH3. So this one here goes to number 2. And that one there goes to number 2. But we do need this part here in the top. This guy here. For our mole ratio. So we're going from grams to moles to liters. So this is the part here that a lot of people were getting really confused about. Was this part here. Okay, we had to have that as grams, and it's N2, so it had to be 28.02. If you did not have this 28.02 here, you weren't going to get the right number. And then we also had to go with our 22.4 liters. And you had to get the right mole ratio in the middle here. And that led you to the 40 liters. So that formula weight there was very, very important. We were going from grams to liters. Anytime you start with grams, you have to do a formula weight. So it's going to be different for each substance. And then if we go down to number 5, this one was a bit more complicated simply because this one was one of these guys that we didn't have. We had to do a chart for it. So we had to highlight. We have this grams over here. We're going from grams. That's one of our conversions. You have to have that on the bottom. We're going to liters. So we are going to do this guy here. There's our 22.4. That's our 22.4 because we're going 2 liters from grams. And then we also have our mole ratio in the middle here, which is this conversion here. And we got that from our numbers up here. We had this one and this one. So if you didn't get the right formula weight, or you didn't quite understand where your mole ratios were coming from, you've got to just keep things in line and keep things well organized here. You have to have your plan. Your plan tells you exactly what conversions you need. Grams to moles, moles to moles, moles to liters. First we're changing what unit we're using, then we're changing our substance, then we're changing our unit. So I hope this kind of clears this up, and I will speak at you later. Thank you very much and have a good night.